In section 8.4, we're going to be finding the GCF, which is the greatest common factor. Find the greatest common factor, at least this is the way we're going to start. This isn't the entire assignment because this is back in the day. Find the greatest common factor of 12 and 30. You got to find what factor goes into them the highest, and the greatest common factor is 6 because 6 goes into 12 and 6 goes into 30. If you don't know that, hang on, sorry, we got an announcement up there. If you don't know that, how would you get to it? You could go into your factor tree and factor these out as far as you can and take whatever is common. We've got a 2 here and a 2 here. We've got a 3 here and a 3 here, but nothing else is common, so 2 times 3 is 6. If you didn't know your greatest common factor, that's how you would find it. We're going to also find the greatest common factor of 18x squared and 42x. Same idea. If you don't know that 6 goes into 18 and into 42, you would break it down to the best that you could. Break down 42, you know it's divisible by 2. Circle anything that has in common, like a 2 and a 3. But they don't have anything else in common. 2 times 3 is 6. But you also would make a tree of x's. It's got 2 x's, and this one has 1 x. How many do they have in common? Just a single x. So the greatest common factor of 18x squared and 42x is 6x, because you've got to find anything that's common for their factors. Let's try it with x's and y's. 6x to the 4th y squared and 15x cubed y. The greatest common factor of 6 and 15. Hopefully you know your multiplication tables well enough that you can just go right to 3. If not, you're going to have to make a tree every time, which is okay, or a calculator. And then you're going to need to find out how many x's do they have in common and how many y's do they have in common. There's a long way to do that. Again, of saying, I can break this down into 4 different x's. And this breaks down into 3 different x's. How many do they have in common? 1, 2, 3, 1, 2, 3. So it would be x cubed. But it's quicker to actually say they can't have more x's in common than they actually have. So the quicker way to do it is say, what's the smallest amount of x's? This is x cubed. This is x to the 4th. They have at least 3 x's in common. How about for the y's? This one has 2, but this one only has 1. So they only have a single y in common. What's the greatest common factor of those two numbers? 3x cubed y. Or I should say those two expressions. 3x cubed y is the greatest common factor. Let's try this one with a's and b's. 4a squared and 3ab. 4 and 3 don't even have a common factor. They don't have a greatest common factor. If you tried to break it down into 2 and 2, 3 and 1, nothing in common. If I broke down the a's, this one has 2 and this one has 1, which means they have a single a in common. But I just told you the shortcut of that is just pick the smallest amount of a's. How many b's do they have in common? This doesn't have any. This has 1. If they don't have any b's in common, then your greatest common factor out of all of that is just a single a. It's the only thing that both terms share, is just the a. And that's okay. Sometimes you have a very small or minimal greatest common factor. Sometimes you have a lot. Sometimes you don't have anything at all. Let's try this one. 14g squared h cubed and 21g to the 4th h to the 5th. Find a factor that goes into 14 and 21. 7 is our guy. We know that they both have g's. How many do they have in common? At least 2. They have 2 in common. You can't say they have 4 in common because this one doesn't have enough. How many h's do they have for a common factor? That one only has 3. This one has 5. So again, you take the smallest exponent that exists on the g's and the h's. And there's your greatest common factor. What are we going to do with those greatest common factors? We're going to divide them. So I'm going to remind you on the quotient rule. This is just a reminder from exponents, the quotient rule. When you divide, we always did the associative property. We're going to associate the 12 and the 4 together. They live together. They're like 12 divided by 4 is 3. Then we're going to associate the x's together. You have x to the 5th and x squared. You're dividing. Reminder that the quotient rule, when dividing, you subtract exponents. Keep the base. So we're going to keep our base of x, and 5 minus 2 is 3. Why do we need the quotient rule? Because that will help when we are factoring monomials. Monomials, remember, means one term. 1 for mono, term. And notice I have a plus sign between these two compared to all the other ones. They said find the greatest common factor between this and this, this and this, this and this. This time we have a binomial, 12x to the 5th plus 8x squared. We have to find its greatest common factor. So find that first. It's GCF, what we just did. What goes into 12 and into 8? The greatest common factor that goes into both is 4. How many x's do they have in common? 2. Always take the smallest number of exponents. So when 4x squared is our greatest common factor, we are now going to divide both terms by 4x squared. Divide both squares by 4x squared. Okay, and we're doing what's called factoring, which means we're basically getting this 4x squared out of these terms. And I'll show you what happens from there. If I take 12 divided by 4, you get 3. 5 subtract 2 is x to the 3rd. Plus 8 divided by 4 is 2. And if I had x squared but I divided by x squared, there aren't any x squareds left. This is what your final answer looks like. It has the greatest common factor out in front, and it has the rest of the factors inside. You know what we actually just did? We undistributed. We undistributed. Well, that's what factoring means. Factor is pretty much the exact opposite of product. Product means multiply, factor means divide. And what do I mean when I said we undistributed? We've done problems like this before. If somebody gave you this problem and said, hey, let's fix this, let's not have this monomial out in front, what would you have done? You would have distributed it. 4 times 3 is 12. When multiplying, add exponents, distribute this. 4 times 2 is 8. Take the x squareds with you. Look at what our original problem was. That's where we started. Every time in algebra or in any math, you learn whatever you learn how to do someday, later down the road, you learn to undo it. That's exactly what algebra math, a lot of it does. When you were little, you learned to add. What is 2 plus 3? You learned that it was 5. And then you learn to undo it later. What is 2 plus x? If 2 plus x is 5, how do we find x? By doing the opposite of adding, you subtract. Everything we do, we have to undo. So what did we just do? We undistributed. Maybe don't put that in your notes because you don't want to think that that's your final answer. This, what was in the box, was the final answers. We factored a monomial. Let's just practice some more of those. Write this down, 4x to the 4th plus 24x cubed. First, you have to find its greatest common factor. And instead of me writing it off to the side and writing it twice, I'm just going to write it right away where it belongs. 4 is the greatest common factor of 4 and 24. Give yourself some space. Move it down. Write it lower so that you have room to divide. Or I guess you could write it off to the side if you want to write it over here. How many x's do they have in common? 3. Always take the least amount of x's. That's your greatest common factor. So again, I don't know if you want to write it lower or off to the side. I'll do it off to the side on this one. Once you find the greatest common factor, you divide each one of them using the quotient rule by 4x cubed. 4 divided by 4 is 1. X to the 4th divided by x to the 3rd, you subtract exponents. 4 minus 3 is 1. Whatever you do, don't you dare give me a factor like that. Blech. No 1s for coefficients, no 1s for exponents. What you have left is just a single plain old x. Plus, keep the plus sign. 24 divided by 4 is 6. X to the 3rd divided by x to the 3rd is x to the 0, but you won't write x to the 0. You'll just tell me there's no x's left. That's your final answer. All of it is your final answer, not just the x plus 6. You have to have the greatest common factor first and then the rest of the factor left over. Notice every time, if there's 2 terms here, there's going to be 2 terms in your parentheses. If there's 3 terms, you're going to have 3 terms. If there's 4, you'll have 4, but you always have to keep the same amount of terms. Let's try this one. Actually, it looks easier, but it might be more complicated. 12x plus 42y, they're both even numbers, so you know that 2 goes into both of them. Keep trying, see if you have to make a factor tree. The highest greatest common factor that you will find is 6. This time I'm going to do it below. I'll just write it lower. 6 goes into 12, but 6 also goes into 42. They don't have any variables in common. This one has an x, this one has a y. They're not the same. So the only greatest common factor is just the 6. So you're going to divide them both by 6. Sometimes it's a number and a variable. Sometimes it's just a number. Other times it's just a variable. 12x divided by 6 is 2x, plus 42y divided by 6 is 7y. Final answer, the whole thing. We'll just practice a few more of these so that you get to see some that are different. 14m plus 35n, a couple more. 14 and 35 each have a factor of 7. They don't share a variable, so again, we're only dividing by 7. 14m divided by 7 is 2m, plus 35n divided by 7 is 5n. Final answer. Let's do 8y cubed plus 12y squared. Greatest common factor that goes into an 8 and into a 12 is 4. They do both have y's in common this time. How many? 2, because you always take the smallest amount. If 4y squared is our greatest common factor, we're going to divide by 4y squared twice. 8 divided by 4 is 2. Y to the 3rd divided by y squared, you subtract exponents, you get just y to the 1st, but don't write your 1. Plus 12 divided by 4 is 3. And y squared divided by y squared is y to the 0. If you ever want to check your answer, distribute it. Distribute it right back together and see if you go back to your original problem. Last couple. What does this one look like? You've got 6x minus 11x squared, and you're looking at 6 and 11, you're like, those don't have anything in common. No, they don't. But there's no number in common. There still is a variable that they have in common. They both share an x. You've got an x there, you've got 2 x's there. They can share 1 x. Always take the smallest amount. So both of these are going to get divided by x. 6x divided by x is just 6. Minus, keep track of your negatives, 11 x squared divided by x. 2 minus 1 is 1, but of course you won't put the 1 there. 6 minus 11x, with the x out in front. So as I showed you before, sometimes they have only a number as a Gary's common factor. Sometimes they have both. Sometimes they have only the x. And lastly, don't let this one trip you up. 6n squared plus 3n. I had said it once already. If you have two terms to start with, you're going to have two terms in your parentheses. Why do I say that? Because if we look at this here, a 6 and a 3 both have a 3 in common. How many n's do they have in common? 3n. Always take the smallest. If you divide this by 3n, 6 divided by 3 is 2. N squared divided by n is n. Plus, if you divide this by 3n, you can't be like, oh, it's gone. It canceled. Because now you don't have two terms. And it's not gone. It doesn't cancel. 3 divided by 3 is 1. The n's is n, 1 minus 1 is 0. The n's are gone because you get n to the 0 power. There are no n's. But 3 divided by 3 is 1. You've got to have that 1 in its place. If there's two terms here, there's 2 terms there. All right, that's it for section 8.4.